we're going to go ahead and finish the second part of chapter 2, section 5. So we're going to do reflection. So last class we did shifts, a vertical and horizontal shift. So please make sure you practice that. And the parent functions in the diagram, those are super important, again, for you to memorize. So looking at reflections, what do we have to know about reflections? Is it reflecting over the x-axis or the y-axis? So looking at these examples or explanations or rules or whatever you want to call it, how can I determine if it's a flip over the x-axis? Is looking at the negative sign. So where is the negative sign placed? In this case, it's in front of your variable, yes, but it's also by itself. What do I mean when I say by itself? Meaning, if you're looking at the first one, there is no parentheses. My negative is not inside my parentheses. So that is determining that it's a flip over the x-axis. So when you say reflection, when I say reflection, what do I mean? Here's my x-axis. And this is saying, okay, if my graph was up here, let's say this is where my graph is. Let me just go ahead and let's make it a U. And I'm reflecting it. It's reflecting over this side. And it's going to be something like that. So reflections mean if I were to fold the paper along the x-axis, let's think of it as a sheet of paper. If I were to fold the paper along the x-axis, I'm printing the image on both sides. So have you guys ever done like that? Paint on one side of the paper, you fold it, and then you open it, and it's reflection. That's what the reflection means. You're just taking it and like you're stamping it on the other side along the x-axis. So that's the same thing with the y. However, looking at my y-axis, I'm reflecting it on my y-axis, it's inside. Meaning it's inside the radical, it's inside the parentheses. So another example could be if I have negative x squared. This is a reflection of my y-axis because my x or my negative is inside my parentheses. Okay, so if you're looking at the difference, again, between x and y, with your x-axis, your negatives are by itself, but with your y-axis, it's included. Okay, that's what I mean when I say inside or outside. But looking at this one, let's just say, okay, here's my y-axis. So my y-axis, let's just say my image was this way. It's going to be reflection going this way. Keep in mind, it could go either way, depending on where it is, okay? So it could be either way, okay? Depends on the reflection, but this is what your reflection looks like. This is what a reflection is. And again, if it's on the outside, if the negative is by itself, it's a flip on the x. If it's inside, it's a flip on the y. All right, before we graph them, I just want to go back to this. This is the page that you really have to know. You have to remember the parent functions and the graph. Okay, when you're graphing, you have to at least give me the first 3 points. When I say first 3 points, I at least mean -1, 0, and 1. I need to see at least these 3 when you're graphing something, okay? And that's the same thing for the end answer. So this one's for absolute value. This one's for quadratic function. Keep in mind, the absolute value is a v. Okay, your quadratic function is more of a parabola, is more of a u. So I have to, again, I'm still seeing the same thing, but make sure I see that curve. And then now I have cubic function. This is my little squiggly lines going up and down. So same thing, I need to at least see the first one, the second one, and the third one. So -1, 0, and 1, 1. I need to at least see those 3, and then you could kind of graph it how you want. Same thing with your cubic root function. I need to at least see that -1, 0, 0, and 1, 1. And then you could kind of graph it accordingly how you want. And then your square root, same thing here, but this one only has 2, 0, 0, and 1, 1. Okay, so I have to see those. Why do I have to see those? Because once we get into shrinking and stretching, your points are going to change, and I need to see those points graphed in your answer. So please make sure I at least see your x values at -1, 0, and 1. Okay, only for certain ones, they're the same. But if you look at it, they're not all the same. So for example, for this one, for the absolute value, it's -1, 1, 0, 1. They all have at least 0, 0, and 1, 1. But then the other values are going to change. You just have to memorize this graph. Or, I mean, it's going to take a while. You could plug numbers in, but that's just going to take too long. So I would say memorize it as best as you can.
Okay.
All right, I'm going to kind of jump around on these questions. So I'm going to go ahead and just do number 10 first. So looking at number 10, this is a reflection. And is it a reflection on the x-axis or the y-axis? This is a y because it's inside, okay? It's included. So looking at it, this is determining and telling me that it is a reflection. So writing it out, I am reflecting over my y-axis. So what's my original parent function? It's the square root of x. And how would I graph the square root of x? Remember, we have to remember the parent function and the graph. So what would that look like? Does anybody remember what kind of graph does that look like? Is it a U? Is it a V? Is it the squiggly lines? Or is it by itself going to the right? Okay, good. So I'm starting at the center. I'm starting at the origin. And I'm at least going to 1, 1. Okay? Going ahead and graphing it. And this is kind of what it looks like. This is my original parent function where the function of x equals the square root of x. But now I have to reflect it over the y-axis. So here's my y-axis. And I am reflecting it this way. So now I'm going to go ahead and do the opposite. Doesn't have to be perfect, but it should look something like this. Let me make this a little bit more curved. Oof, still don't like that. Something like that. Okay, again, does not have to be perfect, but I do have to see these points right here, at least the first one. Okay, let's go ahead and do number 9. So we did shifts yesterday. We did a horizontal and vertical shift yesterday, so please make sure you study that. Looking at this, let's go ahead and do number 9. I kind of gave the class a little trick on how to remember if it's vertical or horizontal shift. So just a refresher. If I have, let's say, x squared or x minus 2, and it's something like this, I kind of told them that we should know that this is a horizontal shift, okay? This is a horizontal shift, and this is a vertical shift. How do I know the difference? Horizontal, I gave them this way. It's up to them if they want to memorize it, or you as well. Horizontal starts with an H. Think of your H as your parentheses, okay? I don't know. It just works for me. So again, here's my H. I have my two numbers, and they're on the inside. They're connected within parentheses. So if it's inside the parentheses, it's a horizontal shift. If it's outside, it's a vertical shift. I mean, that helps me to remember it, but come up with a way for you to remember it, because that's the only way that you're going to remember horizontal or vertical shift. So please make sure you find your own way. So looking at this one, this is a vertical shift. Vertical goes up and down, so I at least know that I'm going up 2 units. I have a negative by itself, meaning it's not inside any type of parentheses, it's by itself. So because it's by itself, it's going to be what kind of reflection? X or Y? it's going to be an x reflection. It's going to be reflected over my x-axis. So again, looking at it, because it's outside, this is going to be a reflection on the x-axis. So my original parent function was x squared. I'm going to go ahead and graph this. So looking at this one, x squared. Remember, you have to remember the parent function and the graph. So graphing it, I'm going to start at 0, 0, and I know I'm at least going to 1, 1 and negative 1, 1. This is my u. This is my parabola, so it's going to have a curve in it. So curve, something like this. Okay, now I'm going to go ahead and use what I have. I personally would like to do the reflection first and then my shift. So when I'm going to reflect it, it's reflecting over my x-axis, which is right here. So it's going to look something like this. Reflecting it means flipping it. I'm flipping it, so it's going to go down now. Let me fix that. And then down. So this is my reflection. Keep in mind, this is not my final answer because I did not do my shift. My shift is I'm going to go up to. So taking that origin part, that reflection part, and I'm shifting. You could think of it as the highest part, the peak of the parabola. Okay, putting my dot there. And again, I'm just shifting everything up 2 units. And then I am going ahead and graphing it. So my blue line is what my final answer is. I'm just going to go ahead and highlight that.
So how are we supposed to do this on like paper?
You're going to have graphs on your paper and you're going to have to graph it yourself. So just like your homework, you need to graph it.
No, I know, but I mean, like, would we then just not do the like purple and black line?
You don't necessarily have to. If it helps you do it, I mean, it's in pencil, you could erase it or you can highlight your final answer. But I need to see the final answer. Are we going to be very specific on your points? Not necessarily, but I at least need to see those 3, okay? I at least need to see those 3 key points. So please make sure you are showing those points because that is what we're going to be checking. As well as once we get to shrink and stretch, those points are very important and I have to see them because it's going to either be a super narrow graph or a super wide graph. So that's something that I have to see. So let's go ahead and look at the next examples on the next slide. Again, we're going to jump around here. Let's go ahead and do 12 first. Looking at it, I don't have any plus. I'm not adding or subtracting anything in the end. All I do is see a sign outside. So I know I'm not shifting anything, but I know I'm going to have some sort of reflection because of this negative. Now, is it a reflection over the x-axis or the y-axis? The x, because again, it's outside. There's no parentheses there. It's not inside my radical sign. So this is x-axis. Why? Because it's outside. We go right outside. Okay, so again, this is similar to the last one we did, but now my negative is on the outside. So I'm still dealing with the same parent function, the square root of x. So I'm going to start at the origin and put 1, 1. And then I'm going to go ahead and graph it. So this is something similar to what it should look like. Again, I at least need to see that starting point and that 1, 1. And now I'm reflecting it over the x-axis. So looking at it, this is my x-axis. So that means it's going to go in the opposite direction. It's just a reflection. So this stays and this curves. So in the end, this is my answer right here. And that's it.
Like how you draw the lines that way, just memorizing like the graph that you showed.
You have to remember that slide with the parent functions in the graph because if you don't know how to graph the square root of x, you're going to have a hard time. So it's just something quick and easy to remember. All right. Now, there really isn't any notes for shrink and stretch, so I'm going to go ahead and kind of write the notes on here. So please write them down. Again, there's no slide for this because it's just quick and easy. So we're only doing a vertical shrink and stretch. This needs to be written down. If you want to add a slide, for all means add a slide, just so you have the space, but I have to see this written on your notes. Okay, all we're doing is a vertical stretch and shrink or shrink and stretch. So when I'm looking at this, what does this mean? You're looking at the number in front of the variable. That's determining if it's a shrink and stretch. To be honest, just memorize it. So if your number is greater than 1, let me put the number 1, that's a stretch. If your number is less than 1, it's a shrink. Okay, just memorize this. That's all I can say. Memorize it, memorize it, memorize it, because it's super important. If you have to label, is this function a shrink or stretch? Just memorize it. So when I'm looking at this question for number 11, what number's in front of my variable? Anybody know? Just look at the number. It's a 2. You have to wait. It's a 2. Looking at it, it's a 2. So that means, is it going to be a shrink or a stretch? It's going to be a stretch. So how are we graphing it? This is when it comes into play where I told you guys it's super important that you have specific points. So yes, there is a 2 here, and that's telling me that this is going to be a stretch. Oof. Stretch. So looking at this, okay, I have my original graph. My original function was x squared, so it's going to look something like this. Again, super important you put those little dots there. It's going to go up here and up here. Okay, when you're doing stretches and shrinks, I want you to plug in the values. Okay, plug in the values. So I'm going to have x and y, and I'm plugging in my values. Let me fix this line. My values, I'm using 0, -1, and 1, or -1, 0, and 1 for my x values. Those are the key points I want you to always use. So now I'm going to plug it in. I'm taking -1, and I'm plugging it in here because I want to know where my graph is. What is it going to look like? It's a stretch. What is that stretch going to look like? This is when it comes into play where you have to be a little bit more specific on your graph. So I'm going to take that -1 and I'm plugging it in. I have 2 times -1 squared. Okay, what's -1 squared? 1, so I'm going to have 2 times 1, which is just 2. Okay, and then this is just going to be 0. If I plug it in, 0 squared is 0, 2 times 0 is 0. And then looking at the next one, I'm going to have 2 times 1 squared. 1 squared is 1, so I'm going to have 2 times 1 equals 2. Now I'm going to go ahead and graph. Please pay attention to what this graph is going to look like. I'm going to kind of zoom in a little bit so you can see. And it's super important that you know where everything's going. So let me go ahead and grab we'll do a pink color. And 0, 0 is going to stay there. So I'm just going to keep my dot there. But now I'm going -1 to a +2. Okay, so my first coordinates right here is -1, 2, and this is +1, 2. Look how my graph is going to change. So -1, 2, +1, 2. And it's going to be more of a skinnier graph. So I'm still going to have a curve. Let me not put it exactly on there. But it's going to be a lot thinner. Okay, so this is now what my new graph is going to look like. It's a stretch. Okay, it's going to be a little skinnier. It's a vertical stretch. Think of I told the class like a rubber band. When you're stretching the rubber band, it's getting skinnier as you stretch it. Okay, so that is a stretch. Now let's go ahead and look at the next one. Looking at number 13, okay? So same thing. Again, this is key. You have to remember this. Looking at my number in front of my variables, this is shrink or a stretch? This is a shrink because I have that 1/2 there. So yes, this is a shrink. And I'm still going to do the same thing. So because of this, it's a shrink. So looking at it, plugging in those key values. -1, 0, 1. This one's pretty easy. It's just a 0. Is it always going to be 0, 0? Most likely. But plug it in, see if it works. And going ahead and solving, I'm going to have 1/2 times -1 squared. What's -1 squared? +1. So I'm going to have 1/2 times 1. What's 1/2 times 1? 1/2, good. Okay, doing the next one. 1/2 times 1 squared. 1 squared is 1. So I'm still going to have 1/2 times 1, which is just 1/2. So my coordinates for this is -1, 1/2. This is still 0, 0. And this is 1, 1/2. So I'm going to go ahead and graph my original, just so you can see it. Remember, I need to see these 3 key points. This is my parent function, where x is squared. Okay, this is my original one, just a rough sketch. Again, I need to see those 3 key points. Now I'm going to go ahead and graph my new one using my new ordered pairs. I'm still going to have 0, 0, but now I have -1, 1/2, +1, 1/2, and this is going to be wider. Okay, and this is what it should look like. So make sure you know the difference between a shrink and a stretch, what it looks like. One's wider, one's smaller. Keep in mind, it's a vertical shrink or stretch, not horizontal. Okay.